Greetings, M Squared here. Today we are going to talk about special right triangles. There are two kinds of special right triangles. One is a 45, 45, 90 degree triangle, which means two angles are 45 degrees, and the other one is a 90-degree angle. And the other one is called a 30, 60, 90 triangle. And these two triangles are used a lot as we get into trigonometry. So the goal today is that you look at a 30, 60, 90 triangle or a 45, 45, 90 triangle, and you're given one side and you can find the other sides just with that one side. So I'm going to kind of show you a shortcut method and then a way that you can do it when you are using similar triangles. So first of all, let's remember what similar triangles are. Similar triangles, there's several different ways to prove triangles similar, but one of them was angle, angle, angle. So that means all 45, 45, 90-degree triangles are similar. And the reason they're similar is because all the angles are the same. And we call that angle, angle, angle. So all 30, 60, 90 triangles are the same because all the angles are congruent. So it was called angle, 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 but we'll go with angle, angle. And then, of course, I sing a little song to remember. So I'm going to share that song with you in just a second because it's not going to make too much sense if I sing it now. First, we're going to look at the two triangles. When we look at a 45, 45, 90 triangle, what we begin to realize is that there's a relationship between the sides, and these two sides, because it's an isosceles triangle. Remember, in an isosceles triangle, the sides opposite those base angles are congruent. So two sides are always going to be the same. And if these two sides are the same, in a 45, 45 degree, 90 degree triangle, this hypotenuse is always going to be the square root of 2 times this. So I have these little formulas down here. If you take a leg, if you have the leg, like if I told you these two sides are 4, then we would know that's 4 square roots of 2. If you have a leg and you multiply it by the square root of 2, you get the hypotenuse. But what if they give you the hypotenuse and you need to find the leg? Well, if you multiply to get here, to get back, you divide. So we're going to say hypotenuse divided by the square root of 2. That's going to be how you're going to get the leg. With the 30, 60, 90 degree triangle, we notice that if we have the shortest side, that's the side opposite the 30 degree angle. If you multiply it by 2, you find the hypotenuse. So that means if you have the hypotenuse, you divide by 2 to find the shortest leg. And if you have the shortest leg, to get to the longer leg, you multiply by the square root of 3. So that means to get back, if you get the longer leg and you want to get back to the shorter leg, you can divide by the square root of 3. So knowing that those relationships always exist in these special right triangles, there's a little song. I didn't make it up, but I heard about it, and I like to sing it to remind myself of this little relationship between the sides. So it goes 30, 60, 90, 1 root 3 and 2, 45, 45, 90, 1, 1 and root 2. Notice they're in order of size. So short leg, long leg, hypotenuse, leg, leg, those are equal hypotenuse. So I might sing that again, but we're going to get to it right now. So remember, I'm going to show you a couple. I'm going to show you a shortcut. The shortcut is memorizing this relationship. And so if you have one side, you just know how to multiply or divide to get to the next side. And the other one is using similar triangles. So we're going to try both of those. Okay, so first one, know which kind of triangle it is. So this is a 30, 60, 90 triangle. I don't see the 30, but I know it has to be 30 because 30 plus 60 is 90, 90 plus 90 is 180. I know that. So in this topic, you're always going to have one of these two. There's only two kinds of special right triangles. All right, so I'm going to use the shortcut first. Right? But first I'm going to sing my song. 30, 60, 90, 1 root 3 and 2. And I'm talking about if I say 30, 60, 90, 1 root 3 and 2. So I'm going to show you 30, 60, 90. I'm just going to write it here. The 1 comes opposite the 30. So I'm going to put like a little 1 there. The root 3 is the other leg. I'm going to put that on top of that. And the 2 is over here. I'm going to put that on top of this. So if I want to use similar ratios, if I want to use ratios to solve it, I can do that. If I want to use my shortcut, I can do that too. So the shortcut says if I have the long leg, to get to the short leg, I divide by the square root of 3. So I would take 15 and divide it by the square root of 3. right? So 15 divided by the square root of 3. And then, of course, I'd have to rationalize my denominator, which means I multiply by the square root of 3 over the square root of 3, unless your teacher doesn't care if you leave it like that. So I would get 15 root 3 over 3. So a lot of denominators there. And then that cancels. And so I know that this is 5 square roots of 3. And then I can check myself. If I multiply that by 3, do I get 15? I mean, by the square root of 3, do I get 15? Yes. Because if I multiply this by the square root of 3, I get square root of 9 times 5. Square root of 9 is 3 times 5 is 15. So that's one way to do it. Once I get the shorter leg, all I have to do if I memorize my little shortcut is multiply by 2. So then this would be 10 square roots of 3. Okay, you might say that's too difficult. I don't want to memorize all that stuff. Okay, so let's do our ratios then. So our ratio just uses these little, I just make ratios with these guys. I still have to remember this. So I say the square root of 3 over 15 is equal to 1 over y. So I put these relationships that I know from my little song or the triangles, and I put them above each appropriate respective side, I should say. And then I make a ratio. So to find y, I said square root of 3 over 15 equals 1 over y. Because I know this relationship exists in every single 30, 60, 90 triangle. And then I just cross multiply. So I'd say root 3 times y equals 15. And then I divide by root 3. And you see, I get the same thing I did over here, and then I had to rationalize the denominator. So it's another way to do it. So I'm going to do it that way for this one. So this is a 45, 45, 90 triangle, right? So 45, 45, 90. I don't do this every time, but we'll leave it up here. It's 1, 1, and root 2, just so you can see it. So now I know that this doesn't have a variable on it, so let's write the variable. And obviously, it's an isosceles triangle, so this one's going to be x as well. So I don't need to do it to all three. If I find this one, I've found that one. So this is 1, and this is root 2. So I'm now making my proportion. So I put the 1 over the x, I put the root 2 over the 7, and I just cross multiply. So x root 2 equals 1 times 7. And if I divide by root 2, I get x equals 7 over the square root of 2. If I rationalize that denominator, I get 7 root 2 over 2. And I don't need to find both of them because they're both the same. All right. And you can double check. If you multiply this by the square root of 2, they would cancel out and you would get 7. So you can kind of, you know that this 1 times the square root of 2 is going to get you your hypotenuse. So you can double check that. All right, here we go. We know that this is 10. Now I'm going to use the shortcut. I know if I have the hypotenuse of a 45, 45, 90 triangle, I know because the triangle looks like this, it looks like 1, 1, and root 2, then I know to get from here to here, I divide by the square root of 2. So I just know that the sides are going to be 10 divided by the square root of 2. I'm going to rationalize the denominator, and I get 10 square roots of 2 over 2. And then I reduce, and I get 5 square roots of 2. So those legs are both 5 square roots of 2. All right, my 30, 60, 90 triangle. If I want to make a little replica of that, it's 1, root 3, and 2. So that I know if I have this leg, to get to the shorter leg, I have to divide by the square root of 3. So I take 12 and divide it by the square root of 3. Which means I need to rationalize my denominator. I get 12 square roots of 3 over 3, and then I reduce, and I get 6 root 3. So x equals 6 square roots of 3. But I know that if I have my short leg and I want to find the hypotenuse, I multiply by 2. So I'm going to take 6 square roots of 3 and multiply by 2. That one's pretty easy. All right, let's try a couple more. So here's my 30, 60, 90 triangle. I know that I have 1, root 3, root 3 and 2. And so I just know that if I have the shorter leg, I love it when I have the shorter leg because it's super easy. Just multiply by the square root of 3. That's 10 square roots of 3. multiply by 2, that's 20. That's always nice when you have an easy one. I have the shorter leg of a 30, 60, 90 triangle. When I go to the longer leg, and remember, I know it's a shorter leg because it's opposite the 30. When I go to the longer leg, I just multiply by the square root of 3. And if I multiply 3 square roots of 3 by the square root of 3, I get 3 square roots of 9, which just ends up being 3 times 3, so that's 9. And to get to the hypotenuse, I just multiply the shorter side by 2, so I get 6 square roots of 3. So our goal is just to find the sides of the special triangles given one of the sides. And you just have to memorize that relationship. That's why it's nice to sing the song 30, 60, 90, 1 root 3 and 2, 45, 45, 90, 1, 1 and root 2. Look, we got the leg. Going from leg to hypotenuse, super easy. You just multiply by the square root of 2. It's always square root of 2 times the leg. Here, since I have the leg, I have to divide by the square root of 2. So that's going to be 2 over the square root of 2. But then I have to rationalize the denominator. Obviously, this is going to be 2 because it's an isosceles triangle. That's what those little marks mean. So if I multiply by the square root of 2 over the square root of 2, I get 2 square roots of 2 over 2. But then I reduce, and this becomes root 2. So if this is your first time doing this, it might seem a little weird. But if you understand that relationship between all those special triangles, and if you memorize your little song or just the relationship between them, you definitely want to keep that in mind and write that down any other time. You can either use proportions or the shortcut. Good luck. M Squared signing out.